IB questions about geometric sequence and a series. The three terms A, 1, B are in arithmetic progression. The three terms 1, A, B are in geometric progression. Find the value of A and of B given that A is not equal to B. This question is about consecutive arithmetic and geometric sequence. For consecutive arithmetic sequence x, y, z, since y minus x equals z minus y, we have 2y equals x plus z. For consecutive geometric sequence, u, v, w, since v over u equals w over v, cross multiply, v squared equals u times w. We will use these two facts to solve this question. A, 1, B. This is an arithmetic sequence. So we have 2 times 1 equals A plus B. Organize. A plus B equals 2. For geometric sequence 1, A, B, A squared equals 1 times B. So we got A squared equals B. We will solve the system of these two equations. Substitution. B equals A squared to the first equation. A plus A squared equals 2. This is a quadratic equation. Equal to 0 first. A squared plus A minus 2 equals 0. A plus 2 times A minus 1 equals 0. So A1 equals negative 2, A2 equals 1. Then we plug back to get B. B1 equals negative 2 squared is 4. B2 equals 1. Since A is not equal to B, so A2 equals 1, B2 equals 1 is not the solution. Just check. A is negative 2, 1. B is 4. This is an arithmetic sequence. Go to the 1AB, 1, negative 2, 4. This is a geometric sequence. So this is the solution to A and B. Question 2. Consider the infinite geometric series 1 plus 3x over 4 plus 3x over 4 squared and so on. For what values of x does the series converge? In the booklet, we are given s sub infinity equals u sub 1 over 1 minus r 1, absolute value of r less than 1. From given this geometric series, we know u sub 1 equals 1 and common ratio r equals 3x over 4 over 1 equals 3x over 4. We want to figure out values of x to make this series converge, which means absolute value of common ratio, which is absolute value of 3x over 4 less than 1. 3x over 4 we can take out from this absolute value. So we got 3 over 4 absolute value of x less than 1 times the reciprocal of 3 over 4 both sides. Absolute value of x less than 4 over 3. Solve this absolute value inequality. X is greater than negative 4 over 3, less than 4 over 3. This is the solution to A. For B, find the sum of the series if x equals 1.3. Since this 1.3 greater than negative 4 over 3, less than 4 over 3, we can use this formula to work out the sum of this series. S sub infinity equals U sub 1 is 1. 1 minus R. S sub infinity equals 1 over 1 minus R. We know the R equals 3 times 1.3 over 4 equals 3.9 over 4. We want to get a fraction 39 over 40. So equals 1 over 1 minus 39 over 40. Try to get rid of 40 by times 40 for every single term. Equals 40 over 40 reduce minus 39 equals 40. So 40 is the sum of this series. Question 3. A geometric sequence has all positive terms. The sum of the first two terms is 15, means s sub 2 equals 15. The sum to infinity is 27. S sub infinity equals 27. Find the value of common ratio and the first term. We will use this formula and this formula to work this problem out. S sub 2 equals U sub 1 times R squared minus 1 over R minus 1. Factor R squared minus 1, R plus 1 times R minus 1 over R minus 1. Reduce. We got U sub 1 times R plus 1 equals S sub 2 is 15. The sum to infinity equals U sub 1 over 1 minus R. S sub infinity equals 27 equals U sub 1 over 1 minus R. We will solve the system of these two equations. For second equation, we need to get rid of this denominator first, times 1 minus R both sides. So we got 27 times 1 minus R equals U sub 1. We will do substitution. Plug U sub 1 equals 27 times 1 minus R to equation 1. We will get 15 equals 27 times 1 minus R times R plus 1. Before you move on, reduce first. 5 equals 9. We can change R plus 1 into 1 plus R. So we get 1 minus R squared. Simplify. 9 minus 9R squared equals 5. We will move negative 9R squared to the left side, 5 to the right side. Don't forget to change the sign. 9R squared equals 9 minus 5 is 4. divided by 9 both sides. R squared equals 4 over 9. So square root both sides. Since in this geometric sequence all positive terms, which means R is a positive, 2 over 3 is the solution to the common ratio. Then we need to plug back in for this usable 1. Usable 1 equals 27 times 1 minus 2 over 3 equals 27 times 1 over 3 equals 9. So usable 1 equals 9 and R equals 2 over 3 are the solutions to question 3.